All right, this is our lesson for Tuesday. We're going to finish our problem 7 through 10, and then we're going to get ready for the notes for tomorrow with average atomic mass. For problem 7, I think we went over this in class, but I'll go over it again just to kind of give you an idea of how to do problems 8 through 10. For problem number 7, calculating percent composition, we're going to take the molecule iron carbide. We got 3 irons, 1 carbon. We're going to get the molar mass of that. And then for molar mass, we're going to convert to grams. Sorry, the molar mass is going to be in grams. And then you're going to take each of the grams, compare them to the total. So the molar mass of iron and carbon, we can see the molar mass of iron is 168. The molar mass of carbon is 12. The molar mass of the total is 180. You take all those numbers and then you're going to compare them. So if I want to find the percent, I don't like that color. If I want to find the percent of iron, I take iron, which is 168. That's sloppy. 168 grams over the total times 100%. If I want to find the percent of carbon, I do the same thing, but now I'm taking what I have of carbon, which was 12, over 180 times 100%. That will give you 93.33% for iron and 6.66% for carbon. And since those are percentages, they should all add up to 100%. For number 8, same thing. You're going to have sulfur dioxide. Now, I purposely left this undone because if you have sulfur dioxide, this was a covalent compound. If you remember the rules, for the first one, if it's sulfur, we just wrote sulfur. We don't have to write mono for the first element. But dioxide tells you that there's 2 oxygens. So sulfur dioxide. Just a quick review of naming covalent compounds. So sulfur dioxide. Again, find the molar mass according to the periodic table. 32 is a big number for sulfur, 16 is a big number for oxygen. So we have 1 sulfur times 32, 2 oxygens times 16. Actually, both of them equal to 32, and the total 64. So you can see that they're probably going to have the same percentage, but let's just show it. Percent of sulfur is 32 grams over 64 grams times 100%. Percent of O2 is also 32 grams over 64 grams times 100%. Number 8 was pretty easy. Gotta speed these transitions up. Slow me down. And of course, 50% plus 50% adds up to 100%. That is your problem number 8. Number 9. For number 9, we can see that we have a bigger molecule, NH4NO3, ammonium nitrate. Quick review lesson. Ammonium was on that half sheet of paper. That half sheet of paper said that ammonium was a +1. And then also on that half sheet of paper was nitrate. That's a -1. That's why you see it as NH4NO3. That was also covalent compounds. Anyway, for this big molecule, NH4NO3, Make sure you know how to do this. You're going to need to do it on the quiz. So NH4NO3, I've got 2 nitrogens. I've got 4 hydrogens, and I got 3 oxygens, if you can see that. Look all those up on the periodic table I've provided for you right here. Then you're going to go ahead and add them all up. It comes out to 80 grams. Now, to find the percent of nitrogen, you take the total of nitrogen over the total of the molecule times 100%. For hydrogen, you're going to take whatever hydrogen we had, which was 4 grams, over the total 80 grams times 100%. For oxygen, you take its total, 48 grams, over the total times 100%. So this one looks bigger molecule, and we have 3 percentages. Still, same problems. Take the part over the whole times 100%, which will give you 35% for nitrogen, 5% for hydrogen, I guess one way you can do it, if you get the first 2, even if you get the first one, it should be 100 minus the percentage to get the average or get the total, because they all have to add up to 100%. But I would rather you do all the problems first and then check to see if they all add up to 100%. 35% plus 5% is 40, plus 60% is 100. For problem number 10, last problem, calculate the percent composition of glucose.